Good morning, grade 11 learners. Welcome to this session on this cold Friday morning, the 19th of June. I am Marita Kotze, the Physical Sciences Education Specialist at Impact, and I will host the webinar today. I'm just going to give another minute for all the attendees to attend this session, so to log in. So let us just see here. It's working. All right. While we're waiting for everybody to log in, I just want to say to you that you please make sure that you download the PDF document to the right or below. And if you do have any questions, you can email me. So yes, all this information in a minute. Right. Okay, let us start. So yes, good morning all the learners, impact and non-impact learners. Welcome to this session. I am Marita Kotze, the Senior Education Specialist for Physical Sciences at Impact. And before we begin this online class, let's cover some of the basics. If you are struggling to hear me, make sure your audio is on and your speaker volume is turned up. You will automatically be muted when joining this session. Should you have any questions, please write it in the question box to the right or below, and I will attend to all your questions after this session, or you can send me an email to academics@impact.co.za or to info@impact.co.za. Download this presentation and additional resources in the handout box below. There are no additional resources today, but please feel free to download this presentation to the right or below on your screen. And please remember to send me your questions. All right, you can send your questions to academic@impact.co.za, or you can write it in the question box today to the right or below on your screen. And you can also send an email to info@impact. And visit Impact's website for the recordings of this session. Here is the link for this the session, and you can click on COVID-19 online schooling past class videos. All right, what I'm doing today is term 1 revision. Why I'm doing this is because it's very important that you make sure that you do know that for the June exam, and that form also the basis of your physics for grade 11 and 12. All right, so the topic area, the knowledge area that I'm going to cover today is mechanics, and the topics that I'm going to look at is scalars and vectors, movement in 1 dimension and vectors in 2 dimensions. You already did scalars and vectors and movement in 1 dimension in grade 10. So that is prior knowledge to you. I'm just going to revise that because that knowledge you need to understand vectors in 2 dimensions. And you need that knowledge as well for grade 12. So if we look at scalars and vectors quickly, you will see here a man with a mass of 150 kilograms, but his weight is 1,500 newtons, 10 times, more or less 10 times more than his mass. So what is the difference between the two of them? This is the amount of matter man consists of, and this is an attraction of an amount of matter to the earth. So yes, that is the vector because there's direction. It's the downward force that's holding this man onto the ground. And remember, that is also the same with you. You can have a mass of 50 kilograms, but weight of 500 newtons. That's the force that's pulling you to the earth. All right. So the scalars and vectors, the topics that I'm looking at is scalars and vectors, direction of a vector, graphical representation, the resultant of a vector, and addition of vectors. All right. Scalars and vectors. I'm sure you're familiar with this. Scalars, no direction. Vectors do have direction. The vector can be represented by an arrow, the arrowhead indicating the direction of the vector, and there's always an angle. All right. So if we look at the two of them, the scalars are distance, speed, time, work, temperature, and the vectors is displacement, velocity, acceleration, force, and momentum. These are terms you are familiar with. All right. So now if we look at some examples, what are the differences between the scalars and the vectors here? Remember, we use SI units, as you can see here, meters, meters per second, kilograms, seconds, meters, joules, watt, Kelvin. You are familiar with degrees Celsius as well, and ampere. And your vectors are the unit plus the direction. Meters west, direction 30 degrees, Newton downwards, meters per second squared east, upwards, west, west. Can you see the direction? All right, so that are examples of scalars and vectors. All right, so now what is a scalar? It's a physical quantity that has only magnitude and a unit, no direction. All right, vector is a physical quantity with a magnitude, unit, and direction. And while the resultant then is the single vector that will have the same effect as the original vectors taken together. Right, so now the direction of a vector, there are three different ways to represent the direction of a vector quantity. The first one is the compass. And if we look at the compass, there's a north, east, south, and west direction. All right, so if we do have a vector here, we will see, say for example, the vector is velocity, and then it's 30 degrees north of east. 30 degrees north of east, so it is in, can you see it's north of east, so you write it as 30 degrees north of east. All right, then we have another vector velocity 2, 30 degrees east of south, and you can see it's east of south, east of south, so make sure that you know how to write the direction correctly. Another way to write it, it's bearings, and that is that we use in navigation of planes and ships. North is given the value of a bearing 0 degrees east, 90 degrees south, 180 degrees, and west is 270 degrees. So if we look at it again, you will see north is 0 degrees, south, east is 90 degrees, south, west. Right, so velocity 1 will then be a bearing of 60 degrees. Not 30 degrees north of east anymore, but 60 degrees. All right, velocity 2 will be 210 degrees. All right, so that is also a bearing that you are familiar with. You can either use, it depends on the scenario and the question and what is asked in the question. So you must make sure that if the direction is given in east and west, you must use east and west, north and south. And if you have to use degrees, and make sure that you do understand what they're asking. All right, so here you can see it will be the bearing of 210 degrees will be measured from the 0 degrees. Right, direction of a vector. Just see. Right, it's just sun on my face. All right, the direction of a vector relative to another vector. All right, will always be according to another vector. If you do have two vectors, it's relative A relative to B, A then A relative to B. In each of the above cases, vector A is at 30 degrees to vector B. 30 degrees vector B. So yes, the direction of a vector is always measured at the tail of the vector. Make sure that you do understand the direction of a vector is always measured at the tail of the vector. All right, so here we do have the arrow, the direction head, and the origin of the arrow. Please, learners, make sure that you use arrows, because if you don't use an arrow, it's not a vector. So you need to put an arrow to the end of the vector and the magnitude. So for example, we have 10 meters east. 10 is the magnitude, meter is the unit, and east is the direction. So this is the graphical representation of a vector. Any vector can be represented by an arrow drawn to scale with the arrowhead indicating the direction of the vector. With the arrow indicating the direction, so 10 meters east due east can thus be represented as what we do have. All right. So what I did here, I use a scale of 1 centimeters equals 1 meter. So this is 10 centimeter. So 10 centimeter will be 1 meter, and therefore it is 10 meters east. All right. So here we do have forces. We have a 10 Newton force and a 20 Newton force and a 30 Newton force. So what is a 30 Newton force? It's when both of them are in the same direction. So you add the two together. 10 Newton plus 20 Newton gives you a 30 Newton resultant vector. Here you do have a 6 Newton and a 12 Newton. So your resultant vector here will then be 6 Newton to the right. This is 30 newtons to the left, 6 newtons to the right. So yes, that is the net or resultant vector. And what is the net of the resultant vector? As I explained just now, it is the single vector that will have the same effect as the original vectors given together. Okay, so you add the two together to get a single vector for both of them. All right, so if they are in opposite directions, you add both of them together again. The one will be in a negative direction, the other one will be in a positive direction. The biggest one, make sure that you choose the direction. Normally we choose the positive side for the biggest vector, right, to make the answer easier because it's a positive answer. So the resultant vector will then be the 30 Newton vector and the 6 Newton vector. All right, so addition of vectors. Here we do have addition of vectors. We have a 10 meters east, 15 meters east, and a resultant vector. 15 meters west, 5 meters east, and a resultant vector. So vectors in the same direction. A man walks 10 meters east, then a further 15 meters east. So what is the question? Find his resultant displacement. Okay, Why is this displacement and not distance? Because they are direction. All right. So your answer will then be the resultant is 25 meters east. All right. Vectors in the opposite direction. A dog walks 15 meters west and then 5 meters east. Find its resultant displacement again. So the resultant displacement therefore will be 10 meters west. Why? Because you have 50 meters west and only 5 meters to the east. So the resultant will be 10 meters west. Right. This is linear vectors. So it is in a straight line. You can just add them together. But movement in one dimension, displacement, velocity, time, and acceleration. Right. We have position, movement in one dimension, distance and displacement, speed and velocity, and acceleration. What is position? It's an object, must be defined in relation to some standard reference point. So this means that you pick a point at every movement is measured from that point in a positive or negative direction. So what do we have here? We have a positive and a negative direction. From here, the city hall here, from to the left, to the west is your negative direction, to the east is your positive direction. If Alex moved from his house, or say for example, Amy is here, she's in the negative direction. All right. So if Alex is moving from his house to Amy's house, it will be in a negative direction. If he's moving 9 kilometers to the right, then that is in the positive direction. It is in a easterly direction. All right. So what is position and reference point then? The position is the place where an object is relative to the reference point. The reference point here is where you are standing on the platform. Okay, this is a train moving from the left to the right, and the boy is standing still in the train. So from your frame of reference, what is happening? From your frame of reference, the boy is moving from the left to the right. That is what you can see. Okay, he is moving from the left to the right. Okay, but actually he is standing still in the train. It's the train that's moving from the left to the right. Okay, so the boy inside the train, which is moving from left to right, that will be his negative direction, and that will be his positive direction. Right. So what is the reference point then? It is a point from which the position of an object is measured. You measured the position of this object. The object is the boy, and the reference point does not move. You are not moving. All right. So movement along a straight line is what you did in grade 10. A description of motion relates to position and time. And the figure below, the car is moved from point A to point B in a specific time period. All right. So what are the definitions that we're looking at today? We are looking at the difference between distance and displacement. Distance and displacement are the second or the third thing that we're looking at. The distance is the actual distance or path length covered by the object, and therefore what will the displacement then be? The displacement is the magnitude and direction, which is a straight line drawn from the starting point to the end point of the motion. So let us have a look. All right, we have a straight line here. So what is that? From A to B. So that will be your displacement. What will be your distance? The dotted line will be your distance. So the straight line AB, say, is 20 meters due east, and the dotted line is the distance or the path length taken to get from A to B, and that can be 30 meters. Okay, but can you see there's no direction? All right, so distance and displacement. The distance will be the actual distance you drive this morning. Maybe you go for a walk, or maybe you go with your bike in the estate where you are living. So, and you cannot, if you drive your bike in the estate, that will be your 5 kilometer will be the distance. All right, so 5 kilometers will be the distance that you go. But the straight line, if it's from where you stop and where you end, that will be the displacement. All right, so speed and velocity. A vector is written with an arrow to differentiate from a scalar. So we use the arrow. So what will be the difference then of speed and velocity? Speed is the rate of change of distance. Speed, therefore, can be calculated with the formula distance divided by time. Distance divided by time. And the symbol for speed is a small v, and distance is a capital letter D, and the time is delta t. The triangle is delta. It's the meaning there's a change in time, and the unit is meters per second, because distance is measured in meters and time is measured in seconds. So it's meters divided by seconds, distance divided by time, and therefore the unit will be in meters per second. So what is velocity then? Velocity is the rate of change of displacement. So displacement or displacement divided by time. So velocity is displacement divided by time, small letter v with the arrow on it to show the difference between the velocity and the speed. And now the displacement is given with a delta x or a delta y. When it's vertical, it's delta y. When it's horizontal, it's delta x. And it's delta t again. But the biggest change and difference here between speed and velocity as direction. All right. So now, adding velocity vectors. What must you do first when you have different velocity vectors? Okay. You always assign a position. You always assign the positive direction. So you have a positive direction. So you have to state the positive direction. So what do we have? A swimmer can swim at 2 meters per second and swims downstream in a river flowing at 3 meters per second due east. Find his resultant velocity. So due east will therefore be your positive direction. So you have to state that, right? A swimmer can swim at 2 meters per second. Draw for yourself the motion, what he did, how did he do it? It's just easier to do at the end calculations for this. And after that, to 3 meters per second east. All right, so now we have a resultant of 5 meters per second east. So what is his resultant velocity if he swims upstream? All right, so now you have an upstream movement. The river flow at 3 meters per second. The boy, once he swims upstream at 2 meters per second. So now his direction will not be east anymore because it must be upstream. So it's in the opposite direction. So your resultant will then be 1 meters per second east. 1 meters per second east. So your positive direction to the right will be positive. That's why we have a positive for the easterly direction and a negative for the westerly direction. Right. You can either write it as east equals positive, or you can just draw the arrow and with a positive on top of it. Make sure that you do your direction first. All right. So what is acceleration then? When we look at acceleration, you will see we have a final velocity, an initial velocity, and a change in time. Why? Because the object will accelerate. It will either be accelerate or decelerate. But we talk about acceleration, a positive acceleration or a negative acceleration for deceleration. So what is acceleration then? It's the rate of change of velocity of an object. Therefore, we can calculate it with the formula acceleration equals change of velocity over time. So the symbol for acceleration is A. Change of velocity is the delta. Delta means change. Delta V and it's a vector, right? You can write the acceleration also with an arrow because acceleration is also a vector. And delta t is the change in time. So therefore we have final velocity minus initial velocity and change in time. All right. So what will the unit then be? Meters per second squared plus the direction. So we only deal in grade 10 to 11, we only deal with problems with a constant acceleration. Uniform is another name for constant acceleration. It means the acceleration doesn't change. So now we have direction of acceleration. If the vehicle, say for example, is running faster, if it's running faster, it will be in the same direction. The positive, the acceleration and the velocity is in the same direction. So your final velocity and your final acceleration will still be positive. All right. It's either in a direction to the right or a direction to the left. All right. Here, the car is driving from the stop sign and it's increasing. So it's acceleration here. Acceleration, but it is in the negative direction. So your final velocity will still be a positive and your final acceleration will still be a positive. Why? Because it's acceleration. Now here you do have the vehicle that started to decelerate. In other words, the acceleration, it's starting to drive slower, it decreases, so the acceleration decreases, so the acceleration is in the opposite direction as the velocity. So if it decreases, you will see that your direction will still be to the right, but please remember that your velocity is negative. The final, it will be in the opposite direction as the acceleration. So here again, you can see the velocity is in the opposite direction than the acceleration. All right. So velocity is in a negative direction, and the acceleration is in it's decelerating. All right. So acceleration of an object in the same direction as the object's velocity increases. If it's in the opposite direction, the object's velocity decreases. All right. So what is different then? In grade 11 and grade 12, we're working now with vectors in 2 dimensions. 2 dimensions, you just work in grade 10 with 1 dimension, grade 10 and 11 and 12, you use vectors in 2 dimensions. All right. So the types of problems that we do have: determining resulting by adding the vectors, resolving vectors into components graphically, and resolving vectors into components by calculation. All right. So these are the 3 types of problems that you do have in grade 11 and 12. Now here, as in grade 10, you work with 2 vectors in a straight line. Here it's 2 vectors with an angle, right? So you have velocity 1, velocity 2, and you have therefore a resultant velocity that's x meter in a 0 degrees angle with a vector. Therefore, there's a direction. Your direction will be in a certain degrees, all right, an angle. All right, so this is a triangle method. You have only 2 vectors. So the resultant, therefore, is the effective value of the 2 vectors taken together. Effective of the 2 taken together. All right. So this is also called the tail to head method. Why? Because the resultant line will be drawn from the tail to the head. The magnitude and direction of the resultant is obtained by drawing a straight line from the tail of the first vector to the head of the second vector. So these are adding vectors that are not linear. When we add in vectors that are not linear, so therefore you have an angle. All right. So what is this then? Now you have the 2 vectors with the same starting point, velocity 1, velocity 2. So what is happening here? Say, for example, you have a donkey car, and you want to, and the donkey car is stuck in the mud. Okay, so you want to move it out of the mud, or it's a car or a Land Rover, whatever you do have. You have to, it's stuck in the mud, and you have to get it out of the mud. So now you can have vehicle 1 and vehicle 2 pulling at a certain velocity. In other words, at a certain angle, pulling the car out of the mud. So therefore, again, the resultant will be an x meter in a certain direction according to one of these 2 velocities. All right. So this is a parallelogram method. Why? Because you complete a parallelogram by drawing parallel lines. The dotted lines are parallel to these 2 velocities, and you measure it, the resultant, from the beginning to the end of the parallelogram. Right. So therefore, taking the magnitude and direction into account, 2 vectors are drawn from the same point. The parallelogram is completed by drawing dotted construction lines, and the resultant will then be the diagonal, which is also drawn from the same point. Therefore, the tail of the 2 vectors from the same point, the tail of the 2 vectors. All right, with an angle. So now, what do we have here? Here we have 5 different velocities. Okay, so, and your resultant will again be from the starting point to the end point. All right, and can you see the arrow shows from the begin point to the end point. All right, so there are 5 different velocities, and you draw it in starting with velocity 1, velocity 2, 3, 4, 5. All right. So what is this method? It's a polygon method, adding the vectors together, as in the triangle method, head to tail, and this method is only used when you have more than 2 vectors. Right. And here we do have 5 vectors. Right. So a summary for all the vectors, how we add them together. The first one was the one that you did in grade 10. Just add them together. Triangle method, the parallelogram method, and the polygon method. All right. So now, how do we resolve vectors into components graphically? All right. We have 2 vectors, and we have. All right. If you do have to resolve it graphically, you can see here we have this is right. These are the 2 vectors. All right. These are the 2 vectors. Or you can draw it. You do have an angle. This is mathematical graphics, the horizontal component, resolving the vectors into components. So what did you do? You do have a vector, all right? And you resolve it in a horizontal component and a vertical component. So the vertical and horizontal component are the effective values of vector 1 in these directions. All right. So what did we do when we in grade 11? It's very time consuming to do a graphical resolving of vectors. All right. So therefore we use calculations, resolving vectors into components by calculations. A component is the effective value of a vector in each direction. So here you do have the vector again, you have the force, and if you do draw it, you do have a horizontal component and a vertical component, and you just complete the triangle, and you must make sure that this is also 90 degrees. So your horizontal component, if you have to calculate it, you will say, all right, it is fx cos theta. Vertical component will be fa sin theta. All right, and so what will we have here? We have here the component on a slope. All right, resolving a vector on a slope into components. So here we do have 2 angles. We have an angle of the slope, and if you draw, say for example, a vehicle or a box that you do have on the ankle, and if you have to draw this will be the weight, will be the one that is down to the earth, and the parallel component and the perpendicular component of this component will be the dotted lines. So make sure if you draw this in a scenario, if you have to do this, you will either draw, if you want to draw all 3 lines, 2 of them must be in dotted lines, right? And or you draw these 2 lines and not this one. But remember, that is in your, for example, in your force diagrams that you did in term 1. All right. So your perpendicular component will be cos theta, and your parallel component will be sin theta. All right. Perpendicular will be cos and parallel will be sin. All right. Here is an example of a car with a mass of 1,500 kilograms is parked on a slope of 30 degrees. So your angle here will be 30 degrees and your angle there will be 30 degrees. So what must you do first? A car with a mass of 1,500 kilograms is parked on the slope of 30 degrees. That is what is given. So what you're first going to do is you draw a labeled diagram. You draw the car as a box with all the forces on it. All right. So that is the parallel and the perpendicular and the weight. All right. But again, this is only for purposes when you draw it. If you draw, you either draw these two or I draw all three of them for you to see that are the three forces. But when drawing it, you either draw this or you put it in. If you do have to make a force diagram or a free body diagram, you need to draw it correctly according to your textbooks. Okay, so this is just an explanation to show you all three the forces on the diagram. So calculate the component of the weight of the car that is parallel to the slope. Parallel to the slope is FG parallel is FG sin theta. Remember we say sin theta, cos theta. Right, it will always be sin theta and cos theta. Okay. All right, so your formula is FG parallel equals FG sin theta. FG is the weight of the car, so it's 1,500 multiplied by 9,8 because you calculate the weight by mg. M is the mass multiplied by the gravitational constant, sin 30 degrees, and your answer is 7,350 Newton, parallel to the level downwards. All right, that is how you write your direction. Your perpendicular to the slope will then be FG cos theta, perpendicular to the level upwards. Remember, it's very important for you to write down your direction. All right. When the car moves further up the road, the slope increases to 40 degrees. How will the components of the weight change respectively? Explain your answer. Now, learners, please. This is an application question for grade 11 and 12. You have to explain when you changes the angle, what will happen? All right. What must be given in an answer? If the slope increases, parallel component increases. The magnitude of the parallel component is directly proportional to sin theta. So here is an explanation of what you are supposed to answer. As the angle increases, so sin theta increases. Therefore, the parallel will increases as theta increases. If the slope increases, the perpendicular component will decrease. So what will happen? Therefore, as the angle increases, the perpendicular decreases. So you have to answer it according to what will happen to the angle, how it will influence the perpendicular and the parallel components. All right, the angular velocity vector. The swimmer heads directly across the river, find his resultant velocity. Where we have previously the swimmer in the same direction or different direction linear, we have now a swimmer that heads directly across the river. Find his resultant velocity. So there you have the bank of the river. The swimmer heads directly across the river, 2 meters per second across the river. But the river flow 3 meters per second. Remember, previously in a straight line, it was in the same direction. The swimmer and the flow of the river is in the same direction. All right? Now, what is the resultant now? Because of the fact that it's not in the same direction, you need to find the resultant by the head and tail method. All right, the triangle method, and your angle will be according to the bank of the river. So therefore, it is 3,6 meters per second at 56 degrees to the bank of the river. So the swimmer gets carried downstream and does not go directly across the river. Your explanation will then be, it will be downstream. There is where he will be found. All right. Angular velocity vectors. If a swimmer wants to go directly across and he is able to swim at 4 meters per second, he must swim upstream. Again, why? Because you have the bank of the river and he wants to be across the river. He doesn't want to be there. He wants to be directly across the river. So what must we do now? Yeah, 3 meters per second. So he has to swim at a certain angle, again, a certain angle to the bank of the river. That's the direction he needs to. But his resultant will be at a 90 degrees. Right. So therefore, he must swim in that direction in order to get to just across the bank of the river. Okay. So that's why we say 2,64 meters per second directly across the river. Directly across the river. That's why we have the angle here as a 90 degrees angle. All right. So again, we have, I include this each and every time because all of the learners are not impact learners and some of the learners attend this class today for the first time. So the additional resource list for physical sciences are the Doxa Henshaw. For impact, we have Doxa Henshaw study guides with summaries and mind maps in it, and also question papers, exercise books. You can download exercise books, or you can buy exercise books from Doxa Henshaw, and you can buy past papers, or you can download it from their website. Here are the website addresses. All right. So what makes the Quanta series unique? The Quanta books are part of the physical sciences packages of the grade 10 to 12 impact learners. If you don't have the Quanta books, it's a very good resource for physical sciences. You can order it at this address. Why? Because it does have, it includes 2 DVDs at the back of the text of the Quanta book, and with key explanations to all the key terminology of physics and chemistry. All right, and there are exam type of questions, as you can see here, and the memorandums are at the back of the physicals, at the back of the Quanta book. So please look at the type of questions that you can see here. Work with the type of questions. See the memorandums at the back of the Quanta book. See how you have to answer your questions. Make sure that you do understand the explanations, and yes, if you don't understand them, you can go on the look at the DVDs and go to the explanations of that specific part of the physics or chemistry again, in order to understand the explanations. All right. The third one is the Science Clinic Notes and Exam Seminars. The Science Clinic Notes and Exam seminars. You can download the Science Clinic notes. It's for free from their website. Here are the link, or you can go and register on their website for the exam seminars. If you are an impact learner, you can. There will be some. If you enroll early enough, sometimes there are discount prices for you. So make sure that you go on their website and register for their seminars, for the exams, for the rest. All right. If you do have any questions, you can send for your questions to impact at in. You can send for your questions to impact.co.za, or you can contact us, or you can send an email to academics@impact.co.za, or you can contact us through this email address. Right. Thank you very much for attending today's class. Hope you find it useful. And yes, see you next time. Have a lovely weekend. Goodbye.